Okay. I'm not able to share. Are you able to see my screens?
Yeah.
Okay. Okay, so now we can start. So good morning, everyone. I'm Philippe Flatresse from Minalogic. I have the pleasure to animate this session of Access webinar. And so we have 5 speakers today from IMEC and FC3 Competence Center. So I propose to start and in order to have enough time for a Q&A session at the end of the webinar. So thank you for registering to this second webinar of the webinar series. And today we will explore the technology offers and collaboration pathways provided by the NanoIC Pilot Line and FC3 Competence Center. So over the next hour, we will look how this initiative can drive innovation and open the door, I expect, for collaborations. So just a quick reminder of ChipGU framework, and the idea of the Access projects is to bridge a gap between supplier, design platform, pilot lines, and manufacturers. And our goal is to connect, of course, end users, including SMEs, design houses, IDM, RTOs with advanced design libraries, EDA tools, and manufacturing. And so we have a large and incredible project consortium, I would say. So it includes regional clusters like Minalogic, Silicon Saxony, and also managed by Blue Morpho. We are also supported by elite partners like IMEC and Fraunhofer CLAT, together with CCC members and industry association. And the idea is to give the capability to European innovator to get access to microelectronics expertise. And as you can see here, we have a bunch of 30 European competence centers, and the objective is to integrate these local CCCs and connect them with Chips Pilot Line and also the chip design platform to build this European network. And the idea is this to create a united and accessible network across Europe. So what are the objectives of the webinar series? We are focusing on 3 quick questions. What exactly are these pilot line and how can end user access to the services? What microelectronics resources exist across our ecosystem, and how European competence centers offer services that complement each other's. So our format is 1 webinar per month, and we try to pair competence center together with pilot line. The first one was with Apex and ChipNL. The one today between NanoIC and FC3, and please mark your calendar for the next session on July 7, and we will present FAME's pilot line together with Asterix. And just about the agenda for the webinar today. Right after me, Giuseppe Fiorentino from IMEC will present NanoIC access model and technology offer. And we will also cover training with Chandra and tailor training approaches with David Mas from FC3 as well. And I hope and I expect we will have a dedicated session of Q&A from 5 to 10 minutes. So the session is, just for your information, the session is recorded, and please, if you have any question, please put them on the chat. And so that's all for me now. I pass the ball to Giuseppe for NanoIC introduction and access model. Thank you.
Thank you, Philippe. I will start to share my screen.
Thank you.
So we have 10 minutes per slot, so the presentation must be quite efficient. So maybe 30 seconds on intro myself. My name is Giuseppe Fiorentino. I work at IMEC as program manager, and among other responsibilities, I am responsible for the work package 8, which is the access to the NanoIC Pilot Line services. So today I'll just share some view on how NanoIC is accelerating beyond 2 nanometer innovation across Europe. Just give you first a small introduction on what is the NanoIC Pilot Line. So this pilot line is meant to provide Europe with a beyond 2 nanometer leading edge system on chip pilot line. We develop core technologies, advanced logic, novel memories, and interconnect technologies that are meant to create a new generation of system on chip and chiplet architecture devices. We do that in multiple fashion. We have 4 main cluster of action, which of course include an infrastructure and equipment part. We are building an extended pilot line which will support fabrication services in the upcoming future. This is happening here in Leuven. The core part of this project, this is a technology project. We are focusing on developing all technologies that Nina will define you later, and they are centered around specific transistor architectures and all other components that are orbiting around this type of technology. How do we make sure that that the Europe can access these technologies? Well, we have created over the last 2 years, basically since the project beginning, a very well structured access process which can lead users to the different services of the pilot line. I think it's very relevant to mention that in Europe today, we are looking forward to create a new generation of semiconductor expert, being either engineers, researchers, scientists, operators that are really there to support the full ecosystem. For that, the NanoIC pilot line has a very strong component on education and workforce development. We have an enormous amount of effort spent there, and Ruxandra will show you later the details of it. The pilot line is a consortium. It's done by different, let's say, other than IMEC, which is the leader. It's done by Cialetti, Fraunhofer, Tyndall, VTT, and CSSNT, all of them covering different aspects of the project. Coming back to the slide that we saw before from Philippe, where are the pilot lines sitting in the pillar 1 of Chips JU? Well, the pilot line, together with the design platform, are what I like to define as the engine of the pillar 1, meaning the whole Chips JU must be supported by actions such as design, but also fabrication and R&D capabilities. That's what the pilot line stands for. As you know, in Europe, we have several pilot lines like Apex, like FAMES, WBG, BICS Europe. So we cover all of us different aspects of the technology, of semiconductor technology, with NanoIC focusing basically on advanced CMOS architectures such as gate-all-around transistors, embedded memories, and advanced interconnect. Here, it is key for me, even the audience, to highlight the role of the competence centers, which are our main contact at every different country in Europe to support the user funnel into the pilot line. Users needs to reach us can reach us through different channels. Competence centers are, for me, probably the most important one, because of course their competence center have a clear view of SMEs, startups, large enterprises on different territory, and can effectively steer users towards the right track of both design development, but also pilot line usage. What are we doing in the NanoIC Pilot Line? Well, that's what you see on the screen. It's probably you have seen such designs in other contexts, but this is how we do envision a high-performance computing system to be in the future, but also it's a very close future. I think some companies are already offering some similar architecture. You have here basically a very complex stack of different chips. It's called indeed a chiplet architecture, which are actually having different function depending on the chip. Why is that? Well, the main reason is optimization. We want to use, for example, very expensive nodes just to focus on the part of the chip that is needed really, that really needs to have this advanced transistor. So we have what we call a logic chip, which is sitting, and let me take my screen again. Yes, which is sitting here. Of course, how do we make sure that this logic unit is talking with the memories? Well, we have the memory chip sitting on the side, and can be multiple memory chips actually sitting all on the side, all connected through what we call advanced interconnect system, which can be sitting over an interposer. In this case, it's an electro-optic interposer with silicon photonic, but can be also just an electrical interposer, and allow to overcome several issues that we see today already ahead of us. For example, the famous memory wall, where now we have not anymore a bottleneck on the pure logic scaling, but we see that how information are exchanged between the logic and the memory are the real bottleneck. So we need to work on that, and we are doing that in several different ways that we will cover in a second. What do we offer in terms of fabrication related, in terms of really access to these technologies? Well, we offer two different services: design pathfinding PDKs and system exploration PDKs. The first are, so design pathfinding PDKs are what we try to provide Europe with items that can help designers, engineers to get familiar with these advanced technologies, things that really cannot be accessed through other services. You will need to access a foundry PDK on 2 nanometer, for example, which is extremely challenging. You can do that in the NanoIC Pilot Line in detail. These PDKs, so this design environment, are not meant to provide fabrication services. They're just exploratory tools. What we do instead with system exploration PDKs, we actually try to link the pathfinding towards also the fabrication of real devices. Those are not yet available, will become available, I think, safe to say, in 1.5 years from now, 1 year and a half, and will be made available for free to the whole European, all European stakeholders. Already today, all our technologies, pathfinding PDKs, are already available on our website, free to download for all European users. A little bit more on the technologies that we are developing. So, as I mentioned before, we have advanced logic, novel embedded memories, and advanced interconnect. As you may remember from the graph before, we are trying to cover different modules and blocks, and we want to put them together. The first, and I think the really relevant part that was developed since the beginning, and already since, I think, the first 6 months, we open to users, to European users, to download, is the advanced logic PDKs. We started with N2 node, so 2 nanometer gate-all-around transistor technologies. Already today, we are able to offer A14, so the next node, offering also, let's say, an extended version of backside power connectivity capabilities. And in the future, we will have A10 and also A7 node, which is actually a different architecture based on CFET. It's an order of magnitude more of complexity. All of these are devices that, let's say, all of these technologies we will be offering as pathfinding PDKs, but we need to really explain to the public that all these devices are fabricated in our fab, and we benchmark our PDK with real devices. They are not just mere theoretical exercises. On the left hand, you have the novel embedded memories, so memories that you integrate in the backend of line of your CMOS chip. We are developing SOT-MRAMs, embedded DRAMs, and also we will offer 3D memory platforms. For novel embedded memories, we already have pathfinding PDKs, but soon we will open to fabrication services. This is also the case for advanced interconnect. This technology is really a powerful tool that can open towards very interesting application, because with advanced interconnect, you can combine, as we saw before, very different chips altogether. So at NanoIC, we are developing advanced two-wafer hybrid bonding based on copper-copper hybrid bonding, plus 2.5D fine pitch redistribution layer technologies, all of that integrated on a silicon interposer. For that also, we will offer, I think even sooner than novel embedded memories, fabrication services accessible to the public. Let's go to the access process, because I think I'm running short in time. How do we make sure people can access these services? Well, we have developed over the last 1 year and a half, 2 years, a quite detailed access flow. Everything starts from our contact request form that can be accessed via basically our website if you want. And already here you can actually open, you can see the different paths are opening. So you can look for pathfinding PDKs or for system level exploration, access for tool manufacturers, and also metrology services. All of that offered in the NanoIC Pilot Line. So the access path of the pathfinding PDKs is very straightforward. You need a DKLA, so Design Kit License Agreement submission, that is then countersigned by our legal department, reviewed, of course, and then European users, I think within a couple of days, can already access it, download the PDK, so it's extremely fast. Concerning system level exploration tool manufacturer, this is a slightly more complex flow, because it needs first an internal strategic assessment to see whether or not there is a match between the technologies that are requested and the technologies provided by NanoIC. If that is the case, we start a stage 3 process, which is a feedback and collaboration proposal. We try really to build a multiple stage check with the potential user and the pilot line and our R&D expert, which are supporting at every step of the process. So we start to create a case together. And if that happens positively, we go to the stage 4, which is actually the project onboarding and initiation. So just to mention, tool manufacturers are indeed very interested to work in the pilot line. They want to showcase their capabilities into an industrial-like environment at 300 millimeter, full 300 millimeter clean room. And we have several active leads at the moment for that. Actually, it's a very, very interesting and sparkling, if you want, activity. Metrology services are also a very important part of the project. The old consortium partners can offer different metrology services, and they are available at the different websites of each and every single partner. There is, of course, a technical assessment that is done directly at every site, and of course, metro service initiation once the services are agreed. Please, to the audience, have a look on our website, and there are several contact forms in case of need, and we have an entire team that is ready to support you in the access request. So don't hesitate to contact us. Thanks. I give the stage to Nina just before this slide, which is basically explaining a bit more in detail what I said before. Please, using the QR code, you can already access the Your Practice page where you can download the first version of our PDKs. We are extremely proud to offer that both on logic, memory, and interconnect, different technologies which will be expanded in the upcoming months. Thank you.
Thank you, Giuseppe.
Thanks.
Hello, good morning, everyone. Can you please confirm if the screen is visible?
Yeah. It is.
Yes.
It is.
Good. My name is Nina Bazzazian, and I'm your contact point for outreach and access in NanoIC Pilot Line project, and it's a pleasure to be here in this webinar to give you a brief overview on the technology offers of the project. So, as Giuseppe showed this slide earlier, I wanted to just briefly have it here as an introduction slide of my presentation to basically as an agenda that I'm going to touch upon advanced logic, novel embedded memories, and advanced interconnect. So starting with the first pillar, the advanced logic. Here I would like to provide an overview on what we have developed in the recent years for advanced logic. Today, our 2-nanometer platform is based on the nanosheet gate-all-around transistor, as you can see here on the cross-section on the right-hand side. And what is provided in the PDKs are actually a set of standard cell libraries plus more than 100 cells, together with abstracted layouts, GDSI layouts, timing models, power models, and most importantly, comprehensive design support. Next to that, one of the key innovation that comes with this technology is the what is called backside power delivery network, which is expected to be somehow foundational technology for future nodes. And the reason behind it is to address the challenges around power delivery, which continues to increase with scaling. So taking that into consideration as well, backside power delivery network is also directly integrated into the PDK. And as you can see here, the A10 and CFET complementary FET pathfinding PDKs are going to be available at a later stage. One important question here is to ask why actually we are investing in such advanced technology developments. So for many years, the industry was able to steadily increase transistor density by continuously fitting more transistors onto a chip. And it was a kind of successful trend following the Moore's law. That is what we call the happy scaling era. But as we moved beyond the 20-nanometer technology nodes, so around FinFET, this scaling became more challenging. And while the introduction of FinFET provided a major boost by enabling continuous improvement in performance and density, it became more clear that the device innovation alone was not really enough, was no longer enough. And so to keep scaling innovation moving forward, the industry increasingly relied on a so-called DTCO, Design Technology Co-optimization, which brings technology development and circuit design together. And this, let's say, close collaboration helped extending density scaling and maintaining this progress of Moore's law that had been predicted for many years. So basically, scaling is no longer just a device problem. It has become a system-level challenge. So this concept is basically the backbone of the offer technologies in this initiative, NanoIC Pilot Line. So the next one, memory technologies, which are a crucial part of our roadmap, starting with the EDRAM technology. This slide seems a bit crowded, but basically it summarizes what is included in NanoIC IXO-based EDRAM PDK. For participants here who are not really familiar with this acronym IXO, it's semiconductor, oxide semiconductor, indium gallium zinc oxide based EDRAM PDK. So we know that today EDRAM is considered one of the most promising memory solutions for AI applications and other, let's say, highly energy intensive computing workloads. The embedded DRAM here, what we have is based on this concept 2T0C. So basically two interconnected transistors which work in a smart way to store information without really requiring a dedicated capacitor. As you can see here in this TEM image, we have test vehicles that were fabricated in our pilot line, and the results were presented in an international conference last year. But looking at it from the PDK perspective, these models are calibrated using the IGZO experimental data, so that like that, the designers could work with realistic device from the early stage. And to make this simulation closer to what you would see actually in a real chip, we included parasitics, which were based on N40 and N7 in the bit cell models. It kind of, but with the goal to give the researchers and designers at the earliest stage this the sensation, the feeling to evaluate the next generation back end of line compatible memory IGZO EDRAM technologies. At this stage, it's worth mentioning that these memory models aren't standalone, because you can combine them with the CMOS front-end technologies from other foundries, for example, to make it possible to explore the full embedded memory systems. The second memory technology is spin orbit torque MRAM. In this case, information is stored within the magnetic layers, which are integrated above the CMOS circuitry. Here you can see the, let's say, the TEM image, so the proof that the test vehicles that we run in our pilot line showing that these memory elements were successfully implemented and integrated above the standard CMOS devices. For this technology as well, an exploration PDK is available to the public, and the access process is what Giuseppe earlier mentioned. The last pillar of NanoIC technology is the very important pillar of advanced interconnect, starting with 3D hybrid bonding, which we know that it is going to play a major role in the future semiconductor system. We know that many future devices will rely on advanced chip stacking on top of each other and that kind of approach. And similar developments are taking place in other pilot lines, for example, APEX, and that is actually what positions Europe in a leadership position. So here we are developing wafer-to-wafer hybrid bonding with extremely fine pitch interconnects. On the right-hand side in this graph, you can see our current electrical data results, which demonstrate approximately 90% yield on the daisy chain test structure. So let's say quite promising. On the process end, the process itself is quite challenging because we bond electrically active wafers through direct copper-to-copper connections. And what makes it challenging from the process perspective is the surface topography, because the requirements are extremely strict, I would say. Like allowable topography variation is around or less than 1 nanometer per micrometer. And beyond this level, the quality of bonding degrades quite fast. And after bonding, of course, the structure is encapsulated with oxide, and then effectively it becomes a single integrated device. For electrical access, we can use the established TSVs through silicon vias and other interconnect structures. For this one, we released PDKs, followed by training activities that were held at IMEC a couple of weeks ago. And hopefully in the future, we will be able to bring some more good news on the fabrication access solutions. And the final technology I would like to discuss is the RDL, Advanced Redistribution Layer Technology. This is another approach for combining multiple dies into a single system. Here, unlike the hybrid bonding, an intermediate interconnect structure is created. As shown here in this cross-section, this yellow part, an organic patterning layer is deposited, for example, a resist, and then filled with copper through a Damascene-like process, and then, of course, CMP'd. And this moment you can repeat this process up to 5 times, so 5 layers with quite tight pitch, 1.3 micron, and then you can assembly on top of that dies up to 20 micron by standard solder bumping, for example, which would be the case of, let's say, die to RTL bonding. In this case, as with hybrid bonding, our plan is to first release the PDKs and then gradually make fabrication services available to external users. But we are aware that the access models are going to be quite tailored for this very technology, because the users will typically bring their own devices. To conclude this section, I would like to add here that an additional advantage here is that because this technology is focused primarily on the back end of line integration rather than the front end, the overall cost can be significantly lower than the associated with advanced CMOS manufacturing. So that was it about the technologies of NanoIC. Now I hand it to my colleague, Ruxandra. Thank you.
Thank you, Nina.
Right. Is my screen visible for everyone?
Yes.
Perfect. So my name is Ruxandra Laure. I'm a project manager here at IMEC, and I'm involved in the NanoIC Pilot Line project on the part on education and workforce development. So as you have seen in the beginning, the pilot line has 4 activity clusters, one of which is the part on education and workforce development, where, as Giuseppe mentioned, we have quite a good offer, from opportunities for PhD students and interns to PDK workshops and so on. And they are all linked in one way or another to the technologies in the platforms that Nina just presented, from logic to memory to interconnect. So in order to support building a skilled European semiconductor workforce, the NanoIC Pilot Line has put together a comprehensive offer of opportunities for PhD students and interns, as I was saying, PDK workshops, but also seasonal schools and expert courses. And I will present them one by one. To start with, here at IMEC, we have a very good offer of research internships, which provide hands-on experience on the premises of IMEC. They are targeted not only at bachelor students, but also master students and PhDs. So the range of attendees, of interns, let's say, is quite diverse and quite large as well. The period also, so the length of the internship also varies, typically between 3 and 18 months. And the latest internship call we have here at IMEC is actually ongoing. It started in May and it continues this month. We are not the only consortium partner that offers internships. Our partner, Tyndall National Institute, offers summer fellowships. These are 3 months research projects complemented by a workshop series in which participants have the opportunity to not only have an immersive experience, but to do hands-on research with experts on site. Since these are summer fellowships, the applications typically open either in December, the year before that of the fellowship, or in January. Internships are not the only offer. So here at IMEC, we offer PhD programs. It's a great opportunity not only to work on groundbreaking research, but also to join the PhD community of IMEC. That is over 800 PhD students coming from more than 40 countries. So it's a very diverse community, and it's a great opportunity to also interact with each other and learn from each other. The next window for PhD applications actually is quite close. It will start on June 22nd, and it will be open until July 8th. So this is a good moment to also share this with your networks along with the IMEC research internships opportunity. So other than internships and PhD programs, at IMEC we also have the IMEC Students Excellence Day. This is a one-day on-site event where IMEC experts give presentations on the main activities here at IMEC, but there are also presentations from our CEO and from top-level management. So it's a very nice way to get immersed into the world of IMEC and to get a glimpse into the activities here. It's open for students from third-year bachelor through master and up to PhD students, all of them, of course, active in a STEM field. And it's twice per year in spring and in winter. Save the date for the next one. It will happen on November 25th. On top of that, we have PhD workshops. So again, Nina gave an overview of the technologies explored here within the NanoIC project. We help onboard participants into these technologies with hands-on experience on the PDKs associated with each technology. So our longest running PDK workshop is that on logic. Up until this year, it was hands-on training on N2, the N2 logic platform. This year, we have supplemented this with training on the A14 PDK workshop. So nanosheet for now, and of course, as the project progresses, we will be moving into other logic platforms like CFET. The logic PDK training is typically 2 days. The first one is made of lectures given by IMEC experts, whereas the second day is dedicated to hands-on exercises with the available PDKs. The A14 Logic PDK is not the only addition to the portfolio of PDKs and associated trainings. This year we have also had our first edition on the EDRAM pathfinding PDK training, and this has happened on May 26th, so not so long ago. This was mainly lectures and ranging from memory landscape, but also to materials, and of course, a deep dive into the functionalities of the EDRAM pathfinding PDK. And last but most certainly not least, we round up our offer of pathfinding PDKs and associated trainings with the RDL and die-to-wafer technologies. We have also piloted training on these PDKs. This was on May 27, so again, not so long ago. And this was a full day starting with presentations on these technologies. However, the bulk of the day was, of course, with hands-on exercises with the newly released PDKs. All of these PDK workshops happen at Leuven with IMEC experts, and it is the audience is quite diverse, from students to academics to professionals. So this is an offer that is open to both universities, research institutes, and the industries. They are meant to serve this again diverse range of participants. Other than internships, PhD opportunities, and PDK workshops, we also have seasonal schools. We have piloted the seasonal schools last November with the NanoIC European Winter School on patterning, with presentations on various topics from CMOS processing, lithography, patterning, photoresist, and so on. And we have had a second edition in March, in the beginning of March. That was the spring school on advanced CMOS, with topics ranging from process integration to characterization, test structures and vehicles, and many more. The winter schools, much like the PDK workshops, are open to not only students, but also to members of the academia, research coordinators, professors, and so on, and of course, members of the industry. The next one will happen right after the Students' Excellence Day this year, so November 26, November 27. And we are confident that it will be as successful as the first two editions, where we had a full house. The auditorium was almost entirely occupied, and we have received very good feedback from the attendees. To close the offer on workforce development and training, we have our expert courses. Again, these are fairly new additions to our portfolio. Starting tomorrow, actually, we have an expert course on epitaxy. The registration, unfortunately, has closed, but much like the internships, the PDK, the PhD opportunities, the PDK trainings, and the seasonal schools, also the expert courses are meant to be ongoing. So these are not a one-off. We are also planning more expert courses in the second half of the year. First of all, an e-learning module, something that interested parties can do at their own pace to also supplement our current effort of on-site trainings. And it is expected to launch in the third quarter of this year. Finally, we have an expert course on metrology, which is prepared by our consortium partners within the Polytechnica Institute of Bucharest. And this is scheduled for the fourth quarter of this year. The exact date will be announced in the coming months. All of our events, all of our opportunities, they are available, they are published on the NanoIC website, which I encourage you to check, especially the events page, which is continuously updated, not only with the events at which the NanoIC Pilot Line is representatives are present, but also with these opportunities in terms of workforce development. And with this, I end my presentation, and I will pass the floor to our next speaker.
Thank you, Alexandra. Your turn, David.
Thank you, Alexandra. I'm going to share my screen here, share this window like this. Okay, so thank you also, Philip, for the opportunity to speak here and to give you some information about our competence center. I will do a very short introduction because Philip, you already showed the position of the competence centers in the whole of the Chips for Europe initiative. So I will mainly focus on our activities, and I will quickly focus on the aspects of skill development and more specifically about our micro-credentials. So what are they and how do we implement them? So my name is David Maas. I'm a Research Valorization Manager at the KU Leuven, and I'm also the coordinator of the Flanders Chips Competence Center. So I said a quick roundup of our activities. It's also more or less how we are structured and how we work. So we have activities on outreach and dissemination. Of course, very important to both know, to get to learn our audience and also, of course, to inform our target audience about our activities. We have the activity of the central contact point. As Philip also said, the competence centers act as a kind of a gateway to other initiatives, but within the Chips for Europe initiative, but also with towards other service providers. As a consortium, as a competence center, we have a lot of expertise on chip development and system integration services. So we are also, of course, offering these services internally. So the services that can be provided by the consortium members, but also, of course, by external parties. So we, together with our client, we search for the right solution and we search for the right partner to implement the solution. Another activity is on pathfinding demonstrators. We are realizing test setups, demonstrator setups, in order to showcase the possibilities of certain technologies, both on the technology side as well as on the business sides. And then, of course, skill development. So the main focus of today. So we are heavily focusing also on organizing and supporting different courses. Skill development is very important for us, and our consortium has, of course, a lot of expertise in setting up courses and trainings. The FC3 consortium consists of the 4 Flemish-speaking universities in Belgium, so KU Leuven, University of Ghent, Free University of Brussels, and University of Antwerp. So let me zoom in on these skill development activities and on these what we call the micro-credentials. Now, we call them micro-credentials, but of course it's an already well-known name. It's a micro-credential. What is it? Yeah, it's kind of a short, dedicated course that can lead to an official accreditation, an official certificate. But what we really want to do is to have a very high involvement of the industry. So we together with the industry, we try to find where the gaps are in the offer. So what really the needs are of the local industry. So it's a kind of a bottom-up definition of the topics of the courses, and also the content of the courses, so the implementation of the courses, is also done in close collaboration with the industry. And a lot of the teachers are also coming from the industry. And the courses are really hands-on. These are not academic ex cathedra courses. This is really hands-on, trying to do a design, trying to do a PCB, really hands-on. Other, let's say, characteristics of those micro-credentials. So it's industry-driven. I already told that. You can have an official certificate. Equivalent aCCCess, it's not the case that this micro-credential is automatically a part of, let's say, a bachelor course or a master education. But the official certificate is equivalent to a certain aCCCess, and so people who get the certificate, they can ask for certain exemptions when they follow certain educational programs. The term upskilling and reskilling is, of course, already very well known by now. So we really want to reach people with a technical background, but not necessarily in chip design. For example, people who are in materials, in science, or in technology, or in AI, but who really want to know, what is a chip? How is it designed? What is inside a chip? So this is more or less the main target audience. So target audience is partly academic, and there, of course, the aCCCess credits are relevant, but not for everyone, of course. Participants from industry, they are not really interested in these aCCCess. They are interested in the relevance of these courses for their immediate job. Also, very important is that we want to really work together with the local ecosystem. So the courses, micro-credentials, are embedded in the local ecosystem. We want to really match the needs of the local companies with and the needs of the local people and what they can offer to each other. And of course, it's a matter of collaboration. We want to collaborate with industry, as I said, but also with academia for the organization, and also with other competence centers and the pilot lines to also define topics and to implement those courses. And to come back a little bit to the aspects of this local embedding, because this is really key to have an immediate impact, as shown by this testimonial. So people, the real impact of those micro-credentials is people being employed by the companies, and this is what we really want to achieve. So this is the main message I want to give. A little bit of upcoming training material now. So we have in October a new micro-credential coming up on the design of printed circuit boards and printed board assembly. These registrations are open since a few weeks, so please have a look at the website, the FC3 website or the micro-credential website. Again, a very industry-driven course and very hands-on. Another upcoming training is a repetition, a second edition of the training that we had last year. So it's about what is a chip design from atoms to AI. This is even for a more broader audience. Okay, you need to have some basic knowledge, but it's not only for let's say microelectronics specialists, but also business development people and policymakers. Also for them, this training will be very relevant. Okay, and then I want to stop by giving a save the date mention. So we will be organizing in September the Flanders Chip Symposium. You know that, yeah, it's a little bit about collaboration. So, and the first step of collaboration is, of course, coming together. And so this is a very good opportunity to come together, just like last year during our launch event, which took place at the same location, by the way. We will put together all the pilot lines and the design platform, give them the floor, give them the opportunity to describe, give information about their offer, their services, and how to access them. And in the evening, we will have a symposium with a number of keynote speeches and a very nice panel. And the topic of the symposium and the panel discussion will be a very relevant one, I would say. So the topic is From Lab to Fab, how to turn semiconductor excellence into manufacturing leadership. So what are the challenges in getting technology out of the fab and into real production and manufacturing? So put this in your agenda. Everyone welcome in September in Mechelen, Belgium. Okay, that's it. Thanks for your attention.
Thank you, David. Thank you to all the speakers. We have few minutes open for questions. So feel free to write a question in the communicator, or yes, or ask your question directly to the speakers. So there is one from Walter Hans. Thank you for the presentation. And does NanoIC Pilot Line plan to work with relevant committees and associations like IEC or CENELC or others to develop industry standard for design, manufacturing, and test?
Yes, I'll take one.
Yes.
Take this one. Not that I'm directly aware. As you have seen during the presentation, the pilot line has a focus, let's say, one step before the industrialization, so lower TRL than real industrialization. But I can imagine for some specific part there could be such activities. I can come back to this person and after the meeting in case.
Okay. Thank you, Giuseppe.
Well,
other question?
Yes.
Other question from the audience? On my side, I have one just about advanced logic. What's the level of maturity of the PDK? Is it silicon influence or more than that? And is there a roadmap for MPW, and how can we access as designer to your environment?
I'll take that too. So for advanced logic, as mentioned during the presentation, the NanoIC Pilot Line will not offer fabrication services. So you will not be able to access physical silicon in this project. The reason is quite straightforward. To have access to a real CMOS, you need to build a full CMOS stack. I mean, N2 would require up to, I guess, 13 metal layers, even a full backend of line, which is by far beyond the scope of the NanoIC Pilot Line per se, where we are focusing on the building blocks and the fundamental building blocks of these new technologies and opening that towards the public. So no, we don't foresee that in the upcoming future, but we do see fabrication services that will be associated to memories and interconnect, which of course are more simple, if you want, and require less learning cycles.
Thank you, Giuseppe. In the meantime, we got another question from Sibony Henrik Knudborn. We have received the feedback that there are many good courses, but the industry does not hear from them. How do you promote your offers?
Yeah, from our side, from FC3, we are working closely together with Flanders Semiconductors, which is the sector organization which represents the whole semiconductor ecosystem in Flanders. And we try to do as much as direct communication through their member mailing list and through their members, besides the more general on LinkedIn and websites and things like that.
On our side, indeed, we are looking into making this more visible to the industry. We are, of course, promoting our events on LinkedIn, not only on the NanoIC webpage. We are communicating them to our partners within competence centers, and of course, in the future, we will be looking to address this as well, to improve on this.
Thank you. Thank you for the answer. Any other questions? We get a thanks from Sibony. So we are 11:01. I propose to close here. Thanks again for attending the webinar, and thank you very much to all the speakers. For your information, you're welcome. The webinar, the replay of the webinar will be available on the aCCCess website, and we will share the link as soon as it is ready for watching the replay. So thank you very much. If you have any question, you can send them to me, and I will redistribute them through the speaker or the competence center. Thank you so much. Thank you.
Thank you, Philippe.
Bye-bye.
Thank you for
Thank you, everyone.
Thank you for attending.
Ciao, ciao. Bye.
Bye-bye.